All right. Hello, folks. Today we'll be going over the final practice exam, question one. With any of these practice exams or exams in general, you always want to read the question all the way through. It always gives you the best idea of having an overarching idea of what the question's asking before you actually go and tackle the problem. So let's read through it. In this question, you will load data from a spreadsheet and select portions to graph. The built-in function unique may be useful to you. Load the data which was given to you in final exam Q1. It's an Excel file into Matlab. Use a script using logical indexing to create a new table containing only data related to methane. Then graph the values for Ireland, Sweden, Switzerland, and Portugal for those in the same figure, title each axis. And then afterwards, verify in Excel. So the first thing you want to do is obviously just download that Excel file and put it into its own folder, which is what we have here. To load something quickly in MATLAB, the easiest way to do it, I always find, is if you right click and click open the file, you'll get the importer here, and we want to upload it as a table based on what the question said. So we're just going to pick table, and we're just going to upload it. Now with this, we're able to actually have it in our workspace here, and we can just take a look at it just so you can get a feeling for what you're looking for. So what we have here is we have 4 columns. We have the country, the year, the value, and the category. It looks like we're only working in methane based on the question, and we only care about Ireland, Sweden, Switzerland, and Portugal. So as you see here, we have like Australia and stuff like that. We really don't care about that. So the first thing we're going to want to do is we're going to want to use the unique function on this, because we don't know if there's any repeat data points, and there's no point looking over all 8,400 points here. So if we run this line of code where Utable is equal to unique of that exam here, we're actually going to get rid of a bunch of repeat numbers. See how we're missing an extra like 500 points in this table. So there must have been some repeat of data that's actually in the question, which is good to know. So then after that, what we want to do is we want to use logical indexing to create a new table containing only data related to methane. Now, if we look at our table, we have in the 4th column, which is the category, we see that we have like sulfur, hexafluoride, and things like that we don't really care about. So how do we use logical indexing here? Well, if we do a string compare, we know that methane exists in the function, right? Or in the table, sorry. So if we use the Utable that we've created, which is the unique table that we created, and we check all the rows and we check the 4th column for methane, what'll happen is you'll see here when we run it, we're going to get a logical index in which all the cases in which 0 occurs means that it didn't match the string methane, and 1 in which the string did match methane. And we can even double check this, right? So if we look at 1, 2, 3, 4, 5, so 5 is methane. So if we go to Utable and we look here and we go down to 5 and we go over, we'll see that methane matches. So that means that this row has methane, and you can go and double check all the way down the rows and make sure that that's actually true if you ever want to double check for yourself. Now that we have a logical index that tells us whether something is methane or something is not methane, we can actually just create a new table. If all we do is we just take only the rows in which there is methane and all the columns, then what'll happen is essentially when we run this line of, when this line of code runs, you'll see that only things that contain the word methane in the 4th category exist. So it has all the rows in which methane exists. So this is perfect, right? So we have all the methanes, and we use the logical index in order to do that. So we've actually just finished the first part of the graph here. Now, the next part is it's saying it wants specific countries. So we can apply the same logical argument that we did in order to determine methane. We can use that string compare to get just things that contain Ireland, just things that contain Sweden, and just things that contain Switzerland, and save them in their own unique table. So if we run this section of code, we'll also get all these indices in which all the values of that methane table have Sweden in them. So if we scroll down, eventually we'll get like a big pack of them, where there'll be a bunch of there we go. Bunch of ones here, right? So that means that this must be the section in which Sweden exists, right? So those are all the rows in which Sweden exists. And in addition to that, also only contain methane because we're only using the table that has only the methane data in them. Something I forgot to mention that's important here is because we're dealing with a table, you have to use the curly brackets here and not round brackets. That's an easy mistake to make because these are a cell array type data set and not a vector or numeric matrix data set. So once we have all the unique vectors, right, that we have here, we can then do it and multiply those together just like we did before, just like we did for methane, and we get our table with Ireland, table for Sweden, table for Portugal. So if we run this section of code, we're going to get all those there too, right? So if I just like pick one, right? So if I pick Ireland here, that's UIreland. If I pick T-Ireland, you'll see that this table only contains the Ireland, and it only contains things that have methane. So this is perfect, right? Now it's going to be relatively easy to graph now that we have all the methane and only for the country of Ireland, and we have all the values and the years for those when we go to plot them by year and by value. So now that we have these individual tables, all we have to do is graph each individual country, right? So the way the question words it is graph these values, graph the value versus year for these countries in the same figure, but different axes. So we're going to need to use subplot, right? We're going to need to be able to get multiple graphs on the same figure. So we're going to create a figure and we're going to create the subplot. Now, all we have to do in order to plot it is we just need the second column and the third column, right? Because if we go to that table again, the second column is the year and the third column is the value. So all we have to use is we just have to call this table here and call this table here. This is going to be all your X values and this is all your Y values. And then I just color coordinated them so it's easier to pick out. You want to also title and label them, obviously, for each individual section. So if we run this entire line of code all the way through, we're going to get a figure like this in which we have Ireland, Sweden, Switzerland, and Portugal. We have the units and the year. I'm assuming this is parts per million, but I don't know. It doesn't give me a unit. But anyway, we can see that we have a graph here with this by the years and by the units. And that's perfect. That's what we're looking for. Now the question asks, to verify that you've actually graphed it correctly, use Excel. So what I've done is I've loaded Excel here. And just to save us some time here, I just scrolled all the way down until I found Ireland methane in Excel. I graphed the units and years. And if we look at this graph, we have a nice graph here. And if I just bring this over and pull this over, you can see very similar trend line as we do in methane in Ireland. I mean, yeah, Ireland and the methane of Ireland and the methane of Ireland for Excel. We see that they're very, very similar. If you wanted to go above and beyond or be able to if this question was more involved, what you could do, what would be another nice thing to do is actually set limits on these. If you notice, each individual unit limits are different. That's why they're on different axes. You see from like 5,000 to 8,000 for Sweden, but for Ireland, we're going from 10,000 to like 16,000-ish. You could set X lim and Y limbs on these in order to go through, right? Like if I make this graph relatively small, you can see that like you're going to get like gaps and for the years here. So you could set limits to make this look prettier. You could also change like the graph things. Instead of it being lines, you can make them dots or whatever. But I feel like this looks relatively nice and the colors make it easier to do. But yeah, so it's a very simple question. Just a lot of typing because you're going to have to be able to make all these lines and plots here. But a good question in order to be able to understand indexing in tables and being able to plot them. So if you have any questions, let us know. Thank you and good luck on the final exam.